So we will be discussing about glaciers. This is the first topic for our uh, finals exam. Okay, so let's start. So we have the Earth's surface. We have glaciers. So what are glaciers? Glaciers are thick ice mass that is formed and accumulated over hundreds of thousands of to millions of years. And then they are formed through the accumulation and compaction and recrystallization of ice. So basically, it is a metamorphic process of your ice. Okay, and of course, in polar latitudes, subpolar climates, and higher altitudes rather. Okay, so this is the distribution of your uh, glaciers in the world. So we have here in the polar environment, as you can see, uh, labeled by the markers. You have the ice caps, highlands, non-permanent ice, and tundras. You have the polar south and north poles, and um, also some parts of the high altitude world. So highest mountains in Africa and in Asia, and they are hard to see because they are quite very small. So we have here South Africa in the tropical temperate area. These are very high altitudes over here, and also in subarctic areas of um, Canada and also Russia. Okay, so these are people climbing glaciers, and this is how a glacier looks like over at high altitudes rather. So you can see they are like flowing rivers, and like flowing rivers, they also carry sediments, the black lines. So these are called moraines. Later we'll be discussing it. So we have the types of glaciers. First, we have the valley, or others call it the alpine glaciers. These are glaciers on valley floors, and width is smaller compared to their length. So their width is actually smaller than their length because they are flowing downwards to the valley floors. That's why they are called valley glaciers. And then we have the ice sheets, which are large scale, sometimes referred to as the continental ice sheets, and flows out in all directions, and then completely buries the underlying landscapes. And then we have the Piedmont glaciers, which forms one or more glaciers that emerge confining walls of the mountain valley. So they are similar to your alluvial fans. And then we have the ice caps, which are similar to ice sheets but are smaller in scale. And they are usually found in the peaks of mountains. So that is how it looks like. So you have the valley glaciers and the Piedmont glaciers coming out of the valley floor. And then we have the ice sheet, which covers the whole landmass. And then here is a Piedmont glacier. So as you can see, I can observe here that it is similar to alluvial fan. So it comes out of your mountains. And then this is how a glacier moves. So these are your factors. You have gravity, collision of ice, your friction on ground surface, mass of overlying ice, and your surface gradient. And the types of movement, you have the plastic flow, which is inside the glacier or in between the top and the bottom, and the basal slip, which is glacial contact on the ground. And you also have markers, which are called the crevasse or the crevice. These are tensile cracks due to the downslope glacial movement. And then that is it. So zone of fracturing, this is where from a shallow portion of glacier up to the top. So this is where your glacier is actually starts to crack, or your crevice starts to form. So your ice is moving slower at the top, and ice is moving slower at the valley wall, and ice is moving faster in between inside the glacier. So by the difference in your velocity, if your glacier is cohesive, it tends to crack. And then also, you also have this plastic ice moving faster, which tends to stretch matter, which cannot be in which glaciers in are relatively rigid, it cracks. And then we also have plastic ice moving at the bottom, which is slower because of the friction from the ice and the bedrock. And then we have here the erosional processes. First one is plucking. It loosens and lifts the rocks and incorporates them into the ice. And rocks are broken through frost wedging. So plucking means they are actually taking up pieces of the rocks uh, from the glacier, the from the base of the glacier. These are actually fractured rocks or jointed, which were part of the bedrock, and then they were plucked out of the um, glacier. And then next we have ablation, uh, which where ablation meaning it scratch it where the ice acts as a sandpaper, and then through the surface of the rock it is pulverized and powdered, and they are actually called the rock floor. So these are the factors of your glacial erosion. First, you have the rate of glacial movement, the thickness of ice, the hardness of the rocks on the ground, and the incorporated ice, and then the erodibility of the ground surface. So this is how it looks like. So we have here the south side and the lee side of a bedrock. Uh, the fractured portion of the glacier of the bedrock, they are actually the weakest portion. So the plucking phenomena is actually due to the downward movement of the glacier, which they actually pick it up, then carried to the glacial side. And then we have the ablation, which are where the previously collected rocks and also the ice is scratching the surface. So the budget of glaciers. So snow is the raw material of glaciers, and glaciers form in the areas where snow falls in the winter, and maybe it will melt in the summer, depending on the climatic condition of the area. So there are areas where it is a permanent winter, and there are areas with four seasons wherein the glacier will disappear. And we have two zones. We have the zone of accumulation and zone of wastage. The zone of accumulation is where the ice is forming, and the zone of wastage is the parts beyond where the zone of accumulation and the ice moves down slope. So basically, where zone of wastage is where you will find the glaciers are going down. And then calving is also the process of creating icebergs. So if your glacier will meet the sea, eventually your ice will break off and turn into an iceberg. So this is how it is. So your cirque and uh, your snow are where your zone of accumulation, and basically the zone of ablation is where the zone of uh, sorry is your zone of wastage, and this is the process of calving where your glacier meets the sea. And we have multiple landforms for the glacier. Glaciated valleys. So these are the V-shaped valleys caused by downcutting, and glacial troughs, which are the U-shaped rather, caused by lateral erosion. So it is basically similar to your fluvial landforms. And we have the cirque or the bowl-shaped depression serves as the focal point of the glacier's growth. Basically, it marks the zone of accumulation. Hanging glaciers, these are tributaries, and then arits, these are sharp-edged ridges. Horns, which are the pyramid-like peaks that is formed by the erosion, glacial erosion. Fjords, these are deep-sided inlets of the sea, and then fjords, which are shallower reliefs than fjords. Then we have the tarn, which are the isolated lake left by the cirque if, eventually if when the glacier melts, and then the paternoster lakes, which are actually multiple glacial lakes which were eventually exposed upon the melting of the glacier. So this is how it looks like. You have this the Horn, the Cirque, the Tarn, the Arit, and the Paternoster lakes. And this is an example, a good example of a fjord. And a fjord, which has a lower relief than a fjord. And sediments of glacial origin. So we have till and tillite. The difference between the till and tillite is where the tillite is a lithified till, and a till and your till is actually an unsorted sediments. These are carried by glaciers and dropped or deposited when the ice melts. And another one is a stratified drift, where apparently they are sorted according to size and weight of the sediments associated with your glacial meltwater. So upon melting the ice, your water actually takes over to sort your um, till. And then you have the glacial erratic, which is a piece of rock that is not native to the underlying lithology and carried by your glacier hundreds of kilometers away from its origin and can range from a pebble to boulder-sized sediments, weighing to several tons. So this is an example of an erratic. So as you can see that is what very big and weighs several tons, and it kind of pops out of the landscape. And this is an example of a till. So this till is not really, they are actually not sorted, and your stratified drift, they are relatively sorted compared to your till. And we have moraines. Moraines are layers of ridges of till, classified based on how and where they are formed in relative to your glacier. So lateral moraine, it forms at the foot of the ridges and adjacent to the glacier, and your sediments came from the fallen rocks of your ridges. So they are they can be formed, they are, you can find them at the foot of your ridges. And then you have your medial moraine. These are formed where your two glaciers meet. So the former lateral moraines, when they meet, when two glaciers meet at the edge of your ridge, your medial moraine will form and will follow uh, the single stream of the former two glaciers. So uh, it can be multiple medial moraines when you have multiple glaciers meeting each other. And then you have the end moraine is the till that forms at the end of glaciers, meaning it is at the foot of the glacier. And then you have the ground moraine, which are the gently rolling layer of till receding from the receding ice front. So your ground moraine is actually formed from the melting of your glaciers. So these are an example. So you have here, as said earlier, when your two glaciers meet, your lateral moraines becomes your medial moraines. And then we have your other formations, which are the outwash plains and your valley trains. These are landscapes in during the recession or melting of the ice. So we have the outwash plain formed in association with an ice sheet, the valley train, when confined in the mountain valley, and the Kettles depression in outwash and plains and valley trains. And you have the other landforms, which is the drumline, uh, streamlined asymmetric hills. So they have also the lee side and the stoss side feature, and points to the direction of the flow. So the direction of the flow is based on where the gentler uh, gentler slope is, or the lee side. And then the esker, made by flowing the streams beneath the glacier, and composed mainly of sand and gravel, and the kame, which is the steep-sided hills. So this is the drumlin. So you have the stoss side and the lee side. So the tapered end is the base, is the direction of the flow. And that ends our lesson for today.